He has given dozens of speaking engagement in plenty of venues to actually describe and formulate a vision of what's ahead, what we have to prepare for. And of course, this brave new world that we're heading into is replete with issues that have to do with cybersecurity. So without further ado, let me introduce Scott. He's now the founder of Amyx Plus, and he's going to actually speak about ambient virtual assistants and what they have to offer to us. Scott, please.
All right, can everybody hear me okay? Great. You know, I love it when I'm kind of set up like this, where you've kind of felt the gravity of cybersecurity and what's happening at state actor level. And of course, they hand it over to me. And what I can tell you is that both as a visionary, a futurist, but also a technologist, is that the future has promise, lots of opportunities. But with those opportunities and the future, it also exponentially increases the threat of cybersecurity. So as I'm speaking to you, and as you hopefully start to get some of the concepts, think about some of the fundamental things that we're going to be challenging and how we're going to be potentially challenging cybersecurity in ways that we've never even thought about. Now, what if I told you that all of us at some point is going to have our own intelligent AI assistant, much like Jarvis, if you're familiar with Iron Man? You know, a few decades ago, many of us had our own secretaries at work. They would answer, there we go. They would answer our phone calls, help with administrative tasks, and handle our travel arrangements. Well, then companies began to trim their cost. And as a result, more of the administrative burden started to fall back on us. Now we have to answer our own calls, schedule our own meetings, and book our own flights. And for those of you that think that our lives are easier with apps, is it? For those of you that had to actually travel outside of this area, let's just think about how much admin work has gone into just getting here today. Last week I was in Germany. Week before that I was in Bosnia. And a few days before that I was in Russia. The sheer amount of time, the coordination, and the mindshare that took to get here is pretty significant. But imagine, what if in the future holds a different kind of promise? What if you didn't have to spend the time worrying about all the mundane details? And what if you didn't even have to interact with dozens and dozens of apps and services? And what if you had your own ambient neural network that handled all your administrative things for you so you can focus on what you do best? Now raise your hand if you know about some of the latest developments with Samsung purchasing Viv. Raise your hand if you're familiar with that. Viv is a virtual assistant. It's effectively a natural language processing system, and the founders are the ones that's responsible for Siri. Raise your hand if you've been tracking with Google I/O and some of the latest announcements with Google Home, Google Wi-Fi, Google Pixel. I'm going to get more into this, but it's very exciting because what we're talking about is this notion of mesh networking, and all of this being controlled by their assistants. Well, to better understand the context of what I'm talking about and some of the macro trends that's in motion, it really takes taking a step back to really understand some of the key drivers that's going to lead us towards this direction. Now, most of us are familiar with cloud computing, right? It wasn't too long ago that many of us, believe it or not, were actually hesitant about cloud computing. Some companies felt that on-premise implementations gave them more security, more protection over their data. And many asked the question, could we really trust the cloud? And what if somebody hacks into their data in the cloud? Well, fast forward, this summer I spoke at one of the largest conferences on cloud in Europe, in London. And I can tell you that the cloud business is booming. And many of the vehement naysayers are today's cloud evangelists. Well, just like 10, 15 years ago, when most of us were skeptics about the cloud, some of us, even in this room, are skeptical about decentralized computing. And again, as I'm speaking, please think about the underlying message and what it means to live in a decentralized world and the fundamental challenges and the boundaries we're going to be pushing in terms of cybersecurity. A major dynamic force in the market is something we call the Internet of Things. It's a force to be reckoned with. It's pushing the direction towards not just decentralized computing, but distributed. And as IoT grows to some 50, perhaps 200 billion smart connected devices by 2020, these smart things are going to represent potentially autonomous things capable of decentralized decision making. We heard about nuclear submarines. Well, what if the inanimate objects around us start to become animate, alive, not just passively sending pub/sub data, but they start to be used in a mesh network environment to control other things? Well, let's first define decentralized. Decentralized computing is the allocation of resources, both hardware and software, to each machine and connected devices. Now, in contrast, centralized computing exists when the functions are carried out in a centralized location, such as in the case of the cloud. With decentralization, autonomous agents will play an important role in how things work. They will be the brains and the logic residing in everything, from driverless cars to delivery drones to connected home products. They will operate individually as well as in a swarm. They will buy and sell services using cryptocurrencies, pay their own costs to maintain and upgrade themselves. They will be a self-sustaining economic unit, but without the bureaucracy. Now, to be perfectly clear, cloud computing isn't going away anytime soon. But rather, what we're talking about is augmenting it and coexisting. Take a look at today's current network topology, from end device, internet gateway to the cloud. Now, this model works fine when you have just a handful of devices in your home, your phone, your smart TV. But once the IoT devices start to surge, eventually in the billions, and that density increases, centralized network model is going to be inefficient. You know, my kids get this point. I have a teenager and a tween. On a Saturday night, they want to watch their Netflix through Comcast. And they're struggling to connect to the internet. And they are complaining, "Dad, the internet's slow. It's not working." And of course, just like any kids, they answer their own questions. "Oh yeah, it's Saturday night. Everybody is on the internet." You see, the network begins to crawl because of this choking point. Now here's a visual diagram that depicts the difference between centralized, decentralized, and distributed. The Internet of Things is changing the landscape of the centralized networks. Think about IoT implementation for a factory or an oil rig or a plot of agricultural land. Now, can you imagine the cost if every sensor had its own mobile data plan? What about running data analytics in the cloud? For those of us that have experimented with Azure, AWS, and others, we know that reaching $20,000 in cloud cost isn't that hard. As the density of IoT devices and their capabilities in terms of CPU, GPU, memory, storage, and bandwidth increase, we're going to start to shift from centralized to decentralized to eventually distributed, where smart things are going to be able to connect with each other rather than going through a centralized network. So that means things like IP-based cameras can run effective as facial recognition system locally. It means that the very things that you see here, from carpet to fabric to even paint, will eventually have nanoparticles and capability to connect with each other. Now, I have two real-life case studies to share that demonstrate that this is not merely a concept. Now, one of our clients in Silicon Valley has developed an IoT system that runs on a tablet. All the sensing of a factory machinery, let's say, as well as environmental conditions, are handled locally on that tablet. Moreover, it runs the heavy-duty analytics on the edge, right on that machine. And only the outliers, the anomalies, and the changes are then shared out to the cloud. All the typical workload that would typically happen on a cloud basis has been brought down to the device level. And what's exciting is that their code base can now be actually placed into any essentially type of device that can support the processing, storage, and memory requirements. So what they've done is they've taken a very standard, complex, multi-tier stack IoT platform that you see just about everywhere from Cisco, GE, IBM, and others, and they've compressed it down and simplified that process. And in the process, they've stripped out the cost of the cellular data plan, as well as the cloud computing and analytics workload. And what's really exciting is that if you're familiar with large IoT platform and implementations, you realize how complex it is. I recently met with a team in Serbia, and they've recently been involved in a Paris implementation for IoT. I've been involved with others where they've been involved with Barcelona and Dubai and so forth. These are very complex, very difficult implementations that can take months, if not years, typically. Well, the kind of implementation that they've developed, the platform, will allow for IoT rollouts to happen in days, not months. We have another client in the security space that we're actually assisting with the development of a wild fog computing network. Effectively, the network tries to utilize the available devices nearby. And what the IP, the intellectual property, is in its ability to actually pull to understand what that device has in terms of processing, memory, storage, bandwidth. And then, for a given job, create an ad hoc network that can actually handle that job and that processing on the fly, as well as handle the drop-offs from inactive to active state, and the management of the nodes dynamically, all the while handling the security that's inherent to a wild fog P2P network. So you see, the transition from a decentralized, distributed world is not happening in 10, 20 years, but it's already starting. And one of the things that's important is, for those that are in school right now, is that the velocity at which innovation is happening has gone from this to this. I've consulted to Samsung just last 2 weeks ago on how they need to think about their IoT strategy. And I can tell you that no longer can we create a product or a portfolio and expect to generate significant revenue and income and ride that for perpetually many years. The cycle is quickening. And the technology and the disruption that I'm talking to you about isn't going to happen methodically. It's going to be rapid. And from now on, because of open source API services, libraries, and just frankly availability of the internet, things are going to be happening at a much faster pace. Another point in this transition is that the cost of computing may be going down, but does it make sense to ingest all that data into the cloud? If you know anything about the Internet of Things, you will find out that many companies are choosing to ingest or take everything from their sensors. Well, knowingly or unknowingly, enterprises are essentially amassing terabytes of dirty data. And then encumbered by data cleansing and transformation, enterprises are going to struggle to derive unbiased data analytics from IoT. According to Harvard Business Review and IBM, bad data costs the US $3 trillion per year. That figure is astounding. Imagine if potential threats, state actors, individuals, could also use these errors, these dirty data, to in effect force people to make decisions in a wrong way. And how could a society that starts to make decisions with poor data affect our governance, our military? Why does bad data cost so much? Well, because all of us, whether we know it or not, rely on it every day. I'll give you an example. Because I had to travel from Germany to New York, and then I had to get on a bus to come to here, and I was quite sick last night. When I went downstairs to ask where the CyberSEED was, they pointed me around the corner of the elevator in Nathan Hill. And I walked in, and it's this tiny little room. So it fits probably no more than 20 people. I'm thinking, oh, this is a venue for the conference. Well, it didn't take me more than 2 minutes to realize this can't be it. So I asked again. The point is, we can make trivial, or we can make something that's significant in terms of decisions and rely on bad data. And when we do that, it's time-consuming and it's fraught with errors. And the reality is, in the face of critical deadlines, what do? We rather rely on bad data than actually go to the data creators and work out the requirements to help eliminate some of the root causes so that the problem doesn't continue. Well, IoT is exacerbating this problem of bad data by dumping unfiltered pub/sub sensor data into the cloud, contributing to a massive dark data lake. And as computing power and memory and batteries and smart devices get better and better, we'll start to see that more of the analytics will start to occur on the edge because of all the reasons that I mentioned. And decentralization will eventually help reduce the overhead, improve security, but also open up some security vulnerabilities as well. It will increase resiliency and efficiency, and it will help meet some of the low latency and high availability and processing requirements. Let's take a look at an example and the need for real-time processing. Here's an example of Boston Dynamics, four-legged Wildcat, that has to perform real-time analytics to be able to jump over obstacles. It can't afford to make a round trip to the cloud and back. It needs to figure out the slope, the heights, and the force to clear the obstacles quickly. So let's watch for just a few minutes. I could watch this all day. Another example is driverless cars. Autonomous cars need to make immediate decisions to avoid collision or running over people, right? They can't afford latency. LiDAR, laser, and radar scanners can scan some 1.3 million data points every time they spin. That's a tremendous amount of data. And they're capable of identifying 14-inch objects from 160 feet away. Now, ask yourself, can they send all this data to the cloud and wait for the calcs to return? No. The computing and the memory and the decisions are made locally on the edge inside the car. It has to. Matter of fact, about a year ago, Samsung identified that one of the core products that they can start to focus on is memory within autonomous cars. Because of the sheer processing and the kind of data crunching that's required, these cars are going to require a whole different set of infrastructure and assets inside the car. So now they're actually starting to develop memory products for autonomous cars, as an example. MIT, your apparent foe, have created a new energy-efficient system on a chip called Iris, designed specifically to implement neural networks capable of handling AI tasks. It's 10 times more efficient than a mobile GPU, which allows devices to run powerful AI algorithms locally, rather than uploading all that data to the cloud for processing. So that means no Wi-Fi, no transmission, and no latency. And can you imagine what this means from vehicles to manufacturing robots, autonomous robots? These advanced things will soon have deep learning algorithms running locally, and they can handle complex computations right there without ever having to go to the cloud. AI. AI is one of those things where I think, again, this presentation is a proponent for AI, but at the same time, as you're in this field of cybersecurity, AI will also be used to create cybersecurity threats. IoT is more than just collecting sensors. It's about applying cognitive intelligence. In a few weeks, I'm going to be speaking at World of Watson for IBM. AI, machine learning, is becoming pervasive, integrated into our daily lives. Raise your hand if you have a phone. You're already using AI. Siri, Viv, Alexa, IBM Watson, all these API services are, for the most part, available. Cognitive science, affective computing, NLP, and other AI disciplines and techniques are maturing. And certainly in the open source and startup communities, we're starting to see implementations and AI libraries that can run locally on the edge. Like I mentioned to you before, Effectiva's video facial recognition algorithms can run locally, right on premise. They never even have to go to the cloud. Moreover, AI is enabling something. It's enabling one-to-many to be able to coordinate and control apps and devices. And it will act as an intermediary. And it will become our ambient cognitive assistant that's going to negotiate with smart things and apps around us. Let me pause here for a second. There's a reason why I use the term ambient. Raise your hand if you think AI is going to be housed within a device. Meaning, AI is going to be resident to a device, physical device. You're wise not to raise your hand, except that one gentleman back there. It's going to be ambient because it's going to collect information from other things around you, but the notion of this AI isn't that it's resident to a device per se. It sounds obvious to have it on your phone, sure, but it's going to be pervasive. Let's take the example of Google Assistant. Google Assistant, which is their rebranded now, can work through what? Their home, the home automation hub. their Wi-Fi, which is going to create that mesh network inside your home, and the pixel. So that one singular interface is going to control all things, and then of course anything that's on that platform through Zigbee, Wi-Fi, LoRa, and other protocols and standards are going to be able to be controlled. Some of you are thinking, how are we going to manage and secure transactions with billions of distributed nodes? I'm hoping that you're asking these questions, because if you think that the current world of centralized computing is complex and it's fraught with cybersecurity threats, the centralized, distributed world is going to change and rock your world. On privacy and security, blockchain is one of just many things we need to consider. But I just want to be sure that you understand it is not the definitive answer to all, but it does help. It's a decentralized ledger system that will support trustless peer-to-peer messaging and secure distributed data sharing with a robust and scalable form of device coordination. Now, blockchain, as we know, is essentially nothing more than a massive distributed cryptographic ledger shared among participating nodes in a network. It keeps a record of every successful transaction, and this allows for trustless transaction activity that facilitates ownership, storage, transfer, and processing of all that information without the need for a middleman to serve as an identity information clearinghouse. So what this means is that transaction, identity verification, trust, reputation, and payments become quantifiable and programmable. So why am I talking about this? What does this all mean? I'm going to tell you about the business benefits, but I'm hoping that you're thinking about the implications. Here's an interesting juxtaposition that visually demonstrates how technology is changing human behavior. The photo on top is from 2005 in St. Peter's Square during the announcement of Pope Benedict's election. Below is a similar picture from 2013 during the election of Pope Francis. Now, if you look at the top, 2005, hardly anyone is holding a mobile phone. Then you look at 2013, the entire crowd is holding smartphones. Now, in the last 2 years, I've spoken over at 50 different conferences all over the world. And I travel extensively. And what do I see consistently, no matter where I am, from Dubai to Singapore to Korea to Germany to Serbia? People staring at their phones in the metro. The smartphone has ushered in an entire new class of consumer behavior, and in turn has reshaped products and services and business models. We use Uber, right? Snapchat, peer-to-peer payments, to name a few. Remember what I told you? Velocity of innovation was like this. That was mobile. With IoT and AI, it's going to be rapid. Expect massive business model disruptions. DApps, decentralized apps being built on Ethereum blockchain, gives us just a small hint of the possibilities to come. From decentralized voting to smart self-validating contracts or document certification. We're just scratching the surface in terms of the possibilities of asset registries and keys that could theoretically be implemented in blockchain. A few weeks ago, I did a thought leadership piece for Qualcomm, which is coming out, I believe, this month or next month, where I shared that many companies will become data companies. I was at the opening of IBM Watson IoT in Munich, and I heard, I believe it was Schneider, the elevator company, how this CXO explained that the future of their company was that of a data company. that they would essentially start to collect information about people, movements, on man walks, elevator, escalators. And that in turn will create new products and services and revenue opportunities that they currently do not exercise. Well, guess what? Some of the companies are going to stop charging an upfront fee for their products. But rather, they're going to charge in a utility-based model, or what I call DaaS, data as a service. So that means that Whirlpool are going to actually give away their washer and dryer without an upfront fee. Good news, right? But they're going to charge you based on the number of loads, the cycles, and the wear and tear. Now, this concept goes for John Deere, Caterpillar, automobiles. But I just want to be very clear. We're not talking about mileage. That's dull, hackneyed. But it's about how you're driving, accelerating, braking, the type of terrain that you're on, and how you're taxing their machines. I mean, is it fair that if you have two parties that have rented a Caterpillar, one is going over ridiculous terrain to rebuild Haiti, another one is just doing a subdivision nearby. Are you going to charge them the same price? No. I have Progressive insurance, and even they get this point. They force you to put these sensors underneath your car. I have it. I don't like it because it keeps on beeping at me. Apparently, I'm not a good driver. It's already measuring these driving behavior to calculate my insurance premium. That is the future of where this is going. By the way, again, I keep on reminding you, as I'm talking about the business benefits, think hard about the fundamental manifestation and the implications of this world of decentralized, of these things coming alive, and what that means. And when we think and talk about IoT, many of us default to small footprint M2M, machine-to-machine nodes, that passively transmit data, right? But the future of IoT, in case it's not clear, it's about intelligent, autonomous things that's capable of much more. Now these robots, Robot Pepper, there's another competitor out there as well. They're starting to come into our homes and offices. In just a few years, most of you, your kids, somebody you know, will own one of these things, including robotic arms that will assist you in your kitchen. They are going to be able to handle real-time processing and autonomy without the need to necessarily go to the cloud all the time. Think about mining robots or autonomous deep water submarines. They have no access to the internet. They have to function all locally without the need for traditional internet and connection. So this all brings us back to what we were talking about, which is the ambient AI agents. These are great, but could these be dangerous? Perhaps. These fundamental shifts in the network, the hardware, and the standards will mean that the future of data management will occur on the edge, and that we as human beings are going to be at the epicenter of this world. Now here's a question for you. Why would in a decentralized world would we need an AI ambient cognitive assistant? Raise your hand if you're okay with controlling thousands of smart things in your home, car, work, public spaces. Raise your hand. Okay, this gentleman. Avoid this gentleman. Now, many of us have seen the rise of AI agents, believe it or not, from X.AI that handles scheduling meetings via email, to Amazon Alexa, to Facebook bots and bots and other applications. There is a major race underway right now between Apple, Google, Microsoft, IBM, Samsung, and startups, such as Viv, that just was acquired, that is vying to become the AI agent for you. Not for a group, but for you. As AI gets more sophisticated and goes beyond their limited bot capabilities to full-fledged cognitive AI, speech, human comprehension and context, as well as emotional analysis. That's an area that we're researching. Notion of friend AI, not friendly AI, but friend AI, that understands us as human beings and tries to connect with us on a level that of a friend or a confidant. Well, all of these things will become eventually meshed into a personal ambient assistant that interfaces with everything around us on our behalf. Now, it's important to note that these agents are not going to be operating without our permission or preferences, but rather you're very much in control. And this is exactly where you come into the picture. How do we ensure that you are, in fact, in control? It will help to orchestrate a workflow or a series of tasks between smart things and systems. Certainly, blockchain will have a play in this with immutable identity and authentication. Nothing can be done without your explicit authorization or predefined preferences. No access can be given to smart things without your permission or key to the general ledger. Let me walk you through a simple use case, and I'm not going to belabor it. But imagine that you're a parent, and you're at work, or you're traveling, like me, most of the time. You instruct your AI agent to pick up your child and take her to piano practice, and then bring her home. Well, your AI agent is going to send a secure, authenticated instruction to the driverless car, your car, and it also communicates with the AI agent at your daughter's school to let them know in advance. When your autonomous car arrives in front of the designated pickup area, there's a secure message that gets sent to the school and the teacher then escorts your child into the car. Well, at that point, that transaction is complete and signed off by both the school AI and the car AI and effectively my AI. And this continues to the piano school and so forth. Well, let's say that I'm not home. My AI is going to communicate to take her home. Open up the garage door, drive in, turn off the engine, close the garage door, and make sure to use the monitoring system, the surveillance system, to see if there's any intruders whatsoever. And once they identify that it's safe, including the use of thermal and other electromagnetic spectrum capabilities, you let the child out. The entryway inside the house is unlocked. And again, that transaction is complete. You see, the future of HCI is changing. Raise your hand if you have an Alexa at home. Raise your hand if you're planning to purchase a Google Home in the near future that's going to compete with Alexa. Excellent. Well, who's ever juggled a suitcase, a laptop, or maybe a cup of coffee, your smartphone, and you're trying to catch a flight or a taxi? Anybody? Well, some of us that are closer to New York City and Hartford, we certainly do that. It's cumbersome. Well, imagine if you have to now do multiple things. Well, that becomes impossible, right? Like juggling. That's why HCI, or human-computer interface, is going to shift from touch to speech and natural language processing and mind control. Why? It's just easier. And sometimes you just don't have a free hand. Now, for those of us that's been using Amazon Echo at home, you've gotten used to calling out Alexa. Alexa, turn on the music. Search for a recipe. Spank my child. Well, perhaps a little bit less obvious is mind control. Next week, I'm going to be speaking and demoing at a conference in Silicon Valley, where I'm going to use mind control to control smart lights and BB-8 robots. But it is not what you think. It is not EEG headsets, like you see here. It is using something called EDP, electrodermal potential, that uses brain electrical signals, but it actually takes it from the skin. And Freer Logic, our partner, is actually putting this technology into the headrest of cars so that it can actually measure your cognitive load to see if you're distracted or drowsy, as an example. Well, we're going to use this technology to control things, to show and to demonstrate that what I'm telling you is not BS, bad trend in science. Raise your hand if you have an iPhone and recently have updated your iOS version to 10.x. Did you notice a new app called Home? That's a HomeKit. It's turning your phone into a smart home automation hub. Now you can use your phone to connect to smart devices in your house. Raise your hand if you read about AirPods, the next generation of earbuds without the jack. Raise your hand if you're excited about it. Why do you think Apple has released HomeKit to users and now the AirPod? And no, it's not because Steve Jobs has passed away. They want to have you start to be trained to using voice control through Siri to control smart things around you, starting with your phone and then the home through HomeKit. Same thing with Google. Same thing with Samsung. Samsung purchased Viv because they want to have their refrigerators, their washers, dryers, and everything else that they create be controlled through Viv. So thanks for sticking with me. I know this is a bit lengthy. Here's the takeaway. Sure, the transition from cloud to edge computing will take a little bit of time, and there will be many technical challenges to come. But the future of edge computing alongside cloud computing isn't that far off. The mix of cloud and edge computing will eventually swing from cloud to edge computing for reasons that I've tried to mention to you. Faster processing, no latency, improved security, hopefully, privacy, and lower cost structure. You see, in the world of IoT, we simply cannot interact with every single device. We need an abstraction layer that can act as an intermediary to orchestrate workflows and tasks and to coordinate things for us. And in this new world, we'll be conversing with our AI intermediary and commanding through the use of speech and our thoughts. So the question isn't when or how or why, but are you ready to embrace the change? Thank you.